Okay, March 23, paper 1, variant 2. Question 1. Measuring cylinder contains water. How much water has been poured into the beaker? We removed some of the water from the measuring cylinder. How much water was removed? This is an easy question. Initially, initially the volume was what? Initially the volume was, okay, let's find the volume. Initially it was 100, 510, 115. Finally, the volume was 50, 55, 60. So you removed 115 minus 60. This is 55 centimeters cubed. Okay? You removed 55 centimeters cubed of water or of liquid. Which row describes the motion of the car at point X and point Y? You have a speed time graph. Speed time graph. At point X, what's happening to the motion? And at point Y, what's happening to the motion? Point X and point Y. What's happening? Okay, point X, can you say it's at rest? No. Constant speed? No, it's not moving at constant speed. No. Point X is not moving. Why is it not moving at a constant speed? Because this is a speed time graph. So what's happening to the speed? The speed is increasing. صح? The speed is increasing. So it's moving with a changing speed, with an increasing speed to be more accurate. At time Y, what's happening? Is it at rest? No, it's actually moving at a constant speed. This is a speed time graph. Okay? Y moving with a constant speed, X moving with a changing or increasing speed. Sure. Yeah, question 3. A ball is dropped in a vacuum. Okay, 4 meters above the surface of Mars. The acceleration of the ball at the height of 2 meters is 3.8 meters per second squared. What's the acceleration of the ball at the height of 1 meter above the surface of Mars? Yeah. What is the acceleration of the ball when you throw a ball on the surface of Mars? What would the acceleration of this ball be? Yell, yell. What would the acceleration of the ball be? Yes, it has to be the same. It has to be the same. This is the acceleration of free fall. On Earth, the acceleration of free fall was what? Was 9.8 meters per second squared. And we all say that the acceleration of free fall on Earth is constant. It's 9.8. What about the acceleration of free fall on Mars? It's 3.8. He said it's 3. You're not required to memorize the number, but on Mars it's 3.8. So at any point on Mars, the acceleration would remain the same. Okay, the acceleration would not be 1.9. It would not increase. Okay, it would remain the same. Okay, I hope it's clear. Question 4. Two objects are placed on a balance. Which properties of the objects can be compared? Which properties of the objects can be compared using this balance? Which properties can be compared using the balance? Can I find the volume? Okay, I can't find the weight and I can't find mass. Can't find the volume. Can I find the density? To find the density, you need the mass and the volume, so you can't find the volume. So the weight and the mass only. يلا يا شباب, I need some help. يلا. Question 5. What's the mass of the water in the pool? How can I find the mass of the water in the pool? Quite easy. You have density, do you have the volume? يلا. How can I find the mass? Density equals ايه؟ يلا حلو. Density equals mass over volume. How can I find the mass? Mass equals density times volume. صح? Density is 1000 and the volume is 50 times 25 times 2, which is 2,500,000 kilograms. Yes. Okay. Question 4. Again, which properties can be compared using the balance? The balance can compare the masses. For example, this is 5 kilograms and this is also 5 kilograms. Okay, 5 kilograms. This is 49 newtons, and this is also 49 newtons. So you can compare both of the masses, but you cannot compare the volumes. Can you find the volume using the balance? No. You need a ruler to find the volume, or you need a measuring cylinder to find the volume. So you cannot use a balance, okay? You cannot use a balance to measure the uh, volume. Yeah. An object is rising vertically. It's moving upwards. It's moving upwards at a constant speed. Yeah. Moving upwards vertically at a constant speed. You have three vertical forces. You have three vertical forces. Which diagram shows the magnitude and direction of the vertical forces? Hmm. It's moving upwards. صح? It is moving upwards. The upward force is U. The drag force is D and the weight is D. Well, it's moving at a constant speed. Which of these diagrams could be correct? يلا. Which of these diagrams could be correct? Hmm. Any ideas? Okay. Can it be A? Can it be A? They are balanced. Yes, they are balanced. But the balance is wrong. Why is the balance wrong? Because the U is upwards. Okay, 2 newtons. Can the drag force be in the same direction as the motion? Can the air resistance be in the same direction as the motion? No, this would be wrong. The friction and or the drag force has to be in the opposite direction. Definitely B and C are wrong. D is the only correct answer because it's moving upwards, okay? This is the motion and this is the friction and the weight. 3 newtons upwards equals 3 newtons downwards. Constant speed. Yeah. Which force produces heating during contact? Produces heating during contact. Hmm. Hell, yes. The only one that produces heating is friction. Quite easy. Well, friction. A meter ruler is balanced at its midpoint. You have a meter ruler. It's helpful to actually draw it. Okay. You have a meter ruler. It's balanced at the midpoint. Okay. So this is the midpoint. Let's say that, um, okay, this is balanced at the midpoint. It remains balanced when the 3 Newton force is hung from the 40 centimeter mark. So this is the 40 centimeter mark, and you have a 3 Newton force at the 40 centimeter mark. A second force is acting at the 80 centimeter mark. Is acting at the 80 centimeter mark. This is the force acting at the 80 centimeter mark. What is the weight of the second load? How can I find the weight of the second load? This is a simple moment question. It's a simple moment question. Clockwise moment equals anti-clockwise moment. Huh? Clockwise moment equals a anti-clockwise moment. The force, the 3 Newton force a is applying an anti-clockwise moment. This is an anti-clockwise moment. The force is applying a clockwise moment. Okay, clockwise moment equals anti-clockwise moment. In this case, we only have two forces. So force times perpendicular distance equals force times perpendicular distance. The clockwise moment is the force times the distance to the pivot. What's the distance of the clockwise moment? What's the distance of F all the way to the pivot? What's the distance of F all the way to the pivot? This is the pivot, It's at the 50 centimeter mark. So why is it at the 50 centimeter mark? Because it's balanced at the midpoint. The distance is what? Is 80 minus 50. The distance is 30 centimeters. So F times 30 equals the anti-clockwise moment, which is the 3 newtons times the distance from 40 to 50. Yeah, the distance from 40 to 50 is what? Is 10. صح? So F equals 3 times 10 divided by 30, which would be 1 Newton. Yes, it would be 1 Newton. Hmm. Any questions? Hmm. شباب, any questions? Hmm. Clockwise moment equals anti-clockwise moment. All you do is find the clockwise moment and you find the anti-clockwise moment. It should be balanced. It should be balanced. The F is acting at the 80 centimeter mark, okay? The F is acting at the 80 centimeter mark and the 3 newtons is acting at the 40 centimeter. You need to, يا شباب, you cannot answer this question without drawing it, okay? You will never be able to answer this question without drawing it. You have to draw it. You have a pivot. This pivot is at the 50 centimeter mark. Okay. This pivot is at the 50 centimeter mark. The distance between the 3 newtons and the 50 centimeters is 10. This is the distance, 10. Okay. The distance between the force F and the pivot is what? Is 30. Why is it 30? Because 80, because all you did was that 80 minus 50 is equal to 30. What about this distance? How did we get this distance? 50 minus 40, which is 10. So the two distances are now what? 30 and 10. F times 30 and the other distance is 3 times 10. 3 times 10 divided by 30 because you need to leave the F alone. So 30 divided by 30 is 1 newtons. 30 times 40 divided by 80. No, that's wrong. Okay. The distance is not 80. The distance is not 80 يا شباب. The distance is from the point, okay, from the point of this force all the way to the pivot. It's not 80. The distance is 30 and the other distance is 10. The other distance is not 40 يا شباب. Okay, the other distance is not 40. This distance is 30 and the other distance is 10 centimeters. Please try to draw the diagram. Please draw the diagram and find the distances. You need to find the distances before solving the question. Okay? Yeah. What is the extension? This is an easy question. When you have a weight of 3 newtons attached to it, what is the extension? Can I find the extension? It's quite easy. 3 newtons. The length was 533. How can I find the extension? Yes, minus 520. It would be 13 millimeters. Which power station produces the greatest atmospheric pollution? Hmm. Greatest atmospheric pollution. Hmm. Which of these produces the greatest atmospheric pollution? Well, it's quite easy. Very obvious. Definitely it's A. Yeah, mister, why is it not D? Why is it not C? Nuclear power station does produce pollution, yes, but we call it nuclear waste or nuclear pollution. It's not atmospheric pollution. Okay, it is not atmospheric pollution. That's why you have to be very careful while stating the type of pollution of each of these power stations. Yeah. Question 11. How much work is being done? Work done equals what? Yeah. I need some help. Work done equals what? Force times A. Hmm. Okay, force times distance moved. F times Z. Hmm. Force times distance moved. Okay, a lot of you said, والله 500. We should multiply the force 500 times 5. Is this right? No, it is wrong. Why is this wrong, mister? It should be 5. The distance is 5 centimeters. Distance has to be in meters. Yes. Distance has to be in meters. So you need to first divide the distance. You need to divide this distance by 100. So the distance would actually be 0.05. The distance would be 0.05 meters. Work done would be 25 joules. Okay, 25 joules. What's the unit of power? I shouldn't even waste any time on this question. Power is what? Hmm. What's the pressure at the base? Divide, eh? Divide by 100. You need to divide by 100. Centimeters to meters, you need to divide by 100. Okay? Divide by 100 to find the distance in meters. Okay. Yeah. Diagram shows a rectangular block of weight 16 newtons. What's the pressure at the base of the block? Can I find the pressure? Pressure equals what? Yeah. This is super easy. Pressure equals, yeah, force over area. What's the force? It's the weight. Huh. 16 over, hmm. What's the area? What is the area? Hmm. This is the area. This is the area. Yalla. The area would be 4 times 5. 16 over 4 times 5. The area is 20. Yes. Okay, so 16 divided by 20 is 0.8. 16 divided by 20 is 0.8 newtons per meter, newtons per centimeter squared. Okay. Hmm. We have a piston. Okay, this was the initial, hmm, 9. I don't care about the 9. The 9 is wrong. Okay, the 9, يا شباب, has nothing to do with the area. The 9 has nothing to do with the area. Okay, it has nothing to do with the area. Because the area in contact with the ground is 5 and 4. Area in contact with the ground is 5 and 4. Yep. Question 14. Okay. Initial position and final position. Initial position and final position. How are the density and the pressure of the gas affected by moving the piston? Okay, if I move the piston inwards, if I move the piston, I'm sorry, the piston actually moved outwards. Okay, if the piston is now moving outwards, how are the density and pressure affected? What will happen to the density and what will happen to the pressure? What will happen to the density and what will happen to the pressure? يلا بسرعة. Hmm. As it moves outwards, the density, yes, it does decrease. Density decreases because the volume. What about the pressure? Yes, the pressure also, decreases. Quite easy. The pressure decreases and the density decreases. Yes. يلا بسرعة. Which statement describe what happens to air particles when the air is heated? When we heat up the air. Hmm. Move slowly. لا طبعا. Move quickly. Definitely. صح. Yes, they do move quickly. What happens when the temperature of the liquid increases? When you increase the temperature of the liquid. Hmm. يلا quickly. The mass increases. Can you say that the mass increases or لا طبعا. The volume of the liquid increases. ماشي. Okay. When the temperature increases, the volume increases, making the liquid less dense or more dense. Is the liquid now more dense or less dense? Yes, definitely. صح, less dense. Okay, it's definitely less dense. Why? This is the convection, صح? When you increase the temperature, the volume increases and then the density decreases, so the hot liquid rises up. In which states of matter can thermal energy be transferred by convection? Convection. By convection. Solids, لا, nothing to do with solids. And liquids only, or liquids and gases? Both liquids and gases, yes. Which of these, okay, which two labeled points are one wavelength apart? يلا. We need the wavelength between 2 points. Wavelength between 2 points. Okay. Could it be, for example, XY? Or YZ? Does W have to do with anything? Like, W is wrong. Definitely W is wrong. So anything that has to do with W is omitted. Is it C or D? Yes, it is between X and Z. This is the wavelength. X and Z is one wavelength. Okay. Question 19. Which row identifies the angles of incidence and reflection? Hmm. angles of incidence and reflection. Which of these is the angle of incidence and which is the angle of reflection? This is the angle of incidence, x, and this is the angle of incidence, y, x and y. Quite easy. يلا. Which row gives the typical wavelength and frequency of red light? We have blue light. صح. Has a typical wavelength of 5 times 10 to the negative 7, frequency of 0.6 times 10 to the power 15. Red light. Okay. Mr. احنا we're not supposed to memorize the wavelengths and frequencies of the light or any electromagnetic wave. Yes, I know. You're not supposed to memorize anything. Hmm. How can you find the typical wavelength or a typical frequency for the red light compared to blue light? What should you do? Write them down. روي كبف صح روي كبف red and blue. Red and blue. How can we compare them both? Which of them, which of these has the highest frequency or highest wavelength? Okay, higher wavelength. Yes, red has a higher wavelength. Red has a higher, yes, wavelength and has a less frequency, a lower frequency. Frequency of the red is lower. Blue has a shorter wavelength and a higher frequency. So whenever we need to choose one of these answers, you need to choose the answer with a longer wavelength and a shorter or a lower frequency. A longer wavelength and a lower frequency. 5 times 10 to the negative 7. Okay. 5 times 10 to the negative 7. I need to find a longer wavelength. 2.4. 2.4 is wrong. So 6.9 or 6.9. Frequency 0.6. I need a lower frequency. I need a frequency which is lower. 0.4 is less than 0.6. It would be C. You need to just choose the longer wavelength and the lower frequency. The longer wavelength and the lower frequency. That's it. Okay. Any problems? Hmm. Yep. This is a really such a trivial, easy question. Huh. Which answer should it be? A, B, C, or D? Ah, definitely. يلا. طبعا it's D. Definitely it's D. A is wrong. A is wrong. Why? Because it splits inside. It has to split inside the prism first. It has to split inside the prism first. Yeah. We have some waves. We have A, B, C, and D. Which of these waves has the longest wavelength? Again, which of these waves has the longest wavelength? What is A? What is B? And what is C and D? A is what? Yep. We need to communicate with a satellite. We need to communicate with a satellite. What is this wave? Communication with a satellite. This should be microwave. Okay. Remote controller. Remote controller. This should be what? Yep. This should be a حلو. Okay. Infrared. Red and green light. Red and green. I just said it. صح. It's the visible light. حلو. Which of these has the longest wavelength? How can I find the longest wavelength? Rami looks great. Rami looks great. The longest wavelength would be microwaves or infrared or light. Definitely microwaves. Definitely the microwaves. Hmm. حلو. Okay. يلا. What is the frequency of this sound? And is it audible to humans? يلا. It has a wavelength of 0.024. Can I find the frequency? Can I find the frequency? Quite Interesting. How can I find the frequency? Sound wave has a wavelength of 0.024 meters. What's the frequency of the sound and is it audible to humans? How can you find the frequency? Hmm. Any idea? Any idea? How can you find the frequency? Huh. Okay. Speed equals wavelength times frequency. Frequency equals speed over wavelength. طب يا مستر, what is the speed of a sound wave? احنا we said we need to memorize the range of speeds for for sound waves. Okay, sound waves. Okay, in air, sound waves traveling in air have a typical speed of around 330 meters per second. You need to, yes, you do need to memorize this number. Okay, you can write it down as 330, 340. Okay, it could decrease a little, it could increase a little. Okay, up to 350 maybe. It could decrease, could go all the way back to 320, 310 maybe. Okay, usually it's around what? It's around 330 meters per second. This is a typical speed for the sound waves in air. So we have the speed, 330, divided by the wavelength, which is 0.024. Okay. If you have the speed and you have the wavelength, you can find the frequency. Yes, let's divide them. Okay. Uh, let's divide them. 330 divided by 0.024, which is around 13,750. Now, this is about 13,750 hertz. So it's not A or B. It is either C or D. Is it audible? Huh? Is this audible? Is this an audible frequency? 13,000 hertz. Yes, it is an audible frequency. Okay. Okay. The whole point is that you need to memorize the speed of sound waves, which is around 330 meters per second. Okay, if you had used 340, it would have been right as well. If you'd used 350, if you had used, for example, 320, okay, all of them would have given you almost the same answer, a very close answer. Yes. Question 24, you have a wire, you have a soft iron wire. Soft iron wire. What happens when you release this um Is it? I'm sorry. I'm sorry. I'm sorry. I'm sorry. Yes, it is C. Yes, I said it's audible. And why did I choose? No, it is definitely C. I'm so sorry. Yes, it is audible. So the frequency is around 14,000 and it is audible to humans. Yes. Okay. Definitely it is C. 24. Hmm. What happens when you have a soft iron wire and you release it? Okay, it's near a magnet. It's near a strong magnet. What happens to this soft iron wire? Huh, does it move away? Iron magnet. Can the iron move away from a magnet? Can never. Can never move away from a magnet. It has to be attracted. It has to move towards the magnet. That's it. It's a soft iron. It's iron. Plus, iron is always attracted to magnet. That's it. Okay, that is it. Man walks across a carpet. He becomes negatively charged. Negatively charged. What happens as he touches a metal object? Okay, as he touches a metal object connected to the earth. Hmm. طيب. The man is now negatively charged, صح? The man is now negatively charged. When he touches a metal, and this metal is connected to the earth or whatever, what happens to the man? Hmm. He's now negatively charged. What will happen to the man? Hmm. Will he gain more electrons? Or would he actually lose the electrons? Definitely, we know that C and D are wrong. We know that C and D are definitely wrong. So would he gain electrons or would he lose electrons? Well, he is now negatively charged. He has too many electrons. He has too many electrons. What should he do with these electrons? He needs to get rid of these electrons. So he actually loses the electrons to the ground. Okay. The electrons move from the man to the ground when he touches the metal wire. Okay? Yeah. We have a wire, okay? Which wire would definitely have a resistance of less, okay, than the standard wire? I need to decrease the resistance. How can you decrease the resistance? Hmm. How can you decrease the resistance? What should you do to the wire length and what should you do to the diameter? Yalla, quickly. Hmm. What should happen to the length? It cannot be longer, it has to be shorter. What about the diameter? Yes, the diameter needs to increase. Okay, when you have a thicker wire, the resistance decreases. Hmm. Diagram shows a circuit which energy transfers occur. Huh. You have a circuit which energy transfers occur. Yeah. Hmm. This is quite easy, صح? Very easy. Definitely, yes. Definitely, it is A. You have the battery, and then the energy is transferred to the lamp, and then the lamp transfers the energy to the surrounding air. Hmm. Quite easy, huh? X, Y, and Z are lamps. X, Y, and Z are lamps. In which of these lamps is there a current? Hmm. In which of these lamps is there current? Yep. In which of these lamps is there a current? Hmm. Okay. Huh. X, Y, and Z. Huh. All of them. Hmm. Okay. But Z is connected to an LDR. LDR, yes, okay. Current could pass quite easily. Y is connected to a thermistor, okay, and the current could pass quite easily. X is connected. What is this? What is this thing? This is a transformer. This is a transformer. If you have a transformer, okay, listen up carefully. Listen up carefully. If you have a transformer, which is connected, okay, you have a transformer, which is connected to a DC supply, a DC power output. If you have a transformer connected to a DC supply, what happens? Nothing happens. Okay, the transformer cannot transform the voltage. It cannot, okay, induce a voltage. It cannot, okay, produce a secondary voltage at all. Why? Because they have a DC input. Whenever you have a DC input, the transformer will not work. Okay. Transform. If this was an alternating current, for example, instead of positive and negative, if you had a wave, okay, if you had this wave, this is an alternating current. If you have this, if you had this wave, okay, if you had this wave, this would have been an AC current. But since you have a positive and negative, this means that this is a DC. This is a direct current. Why? Because the current will always move from the positive. The current will always move in this direction. The current will always move from the positive to the negative terminal. This is a DC current. It cannot operate, okay, the transformers can never operate using a DC current. An alternating current would have had, okay, a wave such as this one, okay? Yes, you do know, you must know this information. You must know that the transformer has to operate using an AC, okay? Transformer has to operate using an alternating current. It will never operate using a DC current. Okay. Okay. Yeah. So, oh, I'm sorry, I didn't choose the right answer. X would not work. Yes, Y and Z would work. So it would be C. Yes, it would be C. Hmm. Question 29. Diagram shows a circuit. Which change causes the bulb in the circuit to become brighter? Yalla, we need the bulb to be brighter. We need the bulb to be brighter. How can it be brighter? How can it be brighter? You need the voltage to increase. You need the voltage to increase. How can you increase the voltage in the bulb? By decreasing the voltage. You need to decrease the voltage in this thermistor. How can you decrease the voltage in the thermistor? By decreasing the resistance. How can I decrease the resistance in a thermistor? By increasing the temperature, because we know that the temperature and the resistance are inversely proportional. So whenever you increase the temperature, the resistance decreases, and the voltage of, again, what voltage? The voltage of, okay, the thermistor. The voltage of the thermistor will decrease. So the voltage of the lamp, okay, the potential difference of the lamp will increase. When the potential difference of the lamp increases, it becomes brighter. So when you increase the temperature, yes, it would be the increase the temperature, resistance decreases, voltage decreases. When the voltage decreases of the thermistor, the voltage of the lamp increases and it becomes brighter. Okay, I hope it's clear by now. Hmm. Question 30. Uh, the kettle has a current of 10 amperes. It's protected by 13 ampere fuse. The owner of a kettle replaces this 13 ampere fuse with a 3 ampere fuse. What will happen? Very easy. What will happen? Hmm. What happens when the kettle is switched on? Now you replaced the 13 ampere fuse with a 3 ampere fuse. What will happen to this kettle? Yeah, what will happen to the fuse? What will happen to the kettle? Any ideas? Hmm. All of them are correct. Definitely wrong. Definitely, this is wrong. Okay. Ah, okay. The fuse melts. The fuse melts, and the kettle might be no. The kettle is undamaged. Actually, the fuse will melt. Yes, the fuse will melt, and the kettle will be undamaged. Why will the kettle be undamaged? Because the current will not even reach the kettle. Why? Because you have a very small fuse. You have a very small fuse. Okay. The kettle needs 10 amperes to operate. It needs 10 amperes to operate. So if you add a fuse, a 3 ampere fuse, what will happen to this fuse? It will melt. It will instantly, okay, it will instantly melt. But the kettle will be undamaged. It will be unharmed. Okay, it won't work at all. The fuse does not, no, it does melt, okay? The fuse does melt, okay? The fuse has to melt, okay? 29 was D. Okay, the fuse has to melt and the kettle will be undamaged. Okay, yeah. Okay, you have a wire which is moved down. Okay, this wire is moving downwards. Three changes are suggested. Which changes increase? You need to increase the EMF. You need to increase the output. You need to increase the induced voltage or the induced current in the wire. Huh. You need to increase the speed of the movement increases. Okay, yes, this will increase the induced current. The magnetic field is decreased. No, if you decrease the magnetic field, the induced voltage will decrease. The direction is reversed. It has nothing to do mm, with the strength of the magnetic field. Yes. Okay, so it's only one. One only is correct. In this experiment, okay, a wire is held above a compass. Wire is held above a compass. An electric current is switched on and the wire and the compass is deflected. Okay, the compass needle is now deflected. Which row explains why this happens? Which row explains why this happens? If you have the wire which is held above, okay, this wire is held above the compass. Hmm. What happens? What happens when you pass a current inside this wire? What happens when you pass a current inside the wire? Huh. There is a magnetic field inside the wire or around the wire. Do we say that the magnetic field is inside the wire or do we say that it's around the wire? Hmm. We actually never say that the magnetic field is inside the wire. It's always around the wire. It's always around the wire. Type. The compass deflects in the opposite direction or the compass deflected in the same direction. What happens when the current is what happens when the current is reversed? Yalla, when the current is reversed, what happens? definitely. يلا in the opposite direction. صح? It has to be in the opposite direction. Hmm. Any questions? Well, over time, the strength of two magnets, okay, not two magnets, of the magnets in an electric motor decreases. Which row describes two ways to keep the motor running at its original speed? Okay, if you want the motor to operate, to run at the original speed, but the magnets are now weaker. The magnets are now weaker. How can you make the motor? Hmm? How can you run the motor at the same speed? يلا, some help. How can you make the motor, okay, run at the same speed? Hmm. Any ideas? What should you do to the current and what should you do to the number of turns? Hmm. You need the motor to be running at the same speed. يلا. What should happen to the motor? What should happen to current? If the magnet decreases, if the magnetic field decreases, you need to increase, yes, you need to increase the current. What about the number of turns? You need to also increase the number of turns. You need to increase them both. Why? Because the magnetic field had decreased. ماشي؟ Okay. يلا. A rechargeable battery contains lithium. يلا. Lithium exists as positive lithium ions. Lithium are positive lithium ions. How does an ion, hmm, how does an ion of lithium differ from an atom of lithium? How does an ion of lithium differ from an atom of lithium? يلا, it's a very simple question. How does the hmm, okay, ion has fewer electrons. Yes, because it's positively charged. It has few. Why? Because it is positively. Hmm, That's it. Nucleus of the ion has less charge. لا. Okay. Nucleus. Okay. Nucleus is unaffected. Nucleus is unaffected. Yeah. This is a simple question. Which statements about the nucleus of this iron nuclide are correct? Huh? Statements about the iron nuclide. يلا. Nucleus contains 56 neutrons. آه. لا طبعا. Nucleon numbers. لا, the nucleon number is 56. Okay. The proton number is 26. Yes. Three only. What is an artificial source of background radiation? Artificial source of background radiation. Hmm. We need an artificial source. No, cosmic are actually natural sources. Okay, natural sources. Yes, radon gas is also a natural source. Plants are also a natural source. Only artificial, okay, the man-made source is the X-ray machines. Yes. Hmm. A sample of radioactive isotope has an initial rate of 128 counts per minute and a half-life of 4 days. How long will it take for the rate of emission to fall to 32 counts per minute? Quite easy. Initially, it was 128. 128 divided by 2 is 64. Then divide by 2 again is a 32. So you reached 32 after what? After two half-lives. After what? Two half-lives. You need to multiply the two half-lives by 4, which would be 8 days. Okay? Total of 8 days. Approximately how long does it take the moon to make one complete orbit of the Earth? The moon rotates around the Earth in how many hours, or days, or one season? It's definitely not one season. Yes, it has to be 1 month. Okay, 28 days, 29 days, 30 days. The sun has a mass of 2 times 10 to the power of 30 kilograms. Which element accounts for the most, for most of this mass? Most of the mass in the, yes, in the sun is hydrogen. Okay. Nearest star to the sun is Proxima. It's at a distance of 4.2 light years. Which statements are correct? Which statements are correct? Telescope images, okay, show it as it was 4.2 years ago. Telescope images show it as it was 4.2 years ago. Yes, this is correct. Yes. Okay. If a spacecraft near Proxima Centauri sends a radio message to the Earth, it would take 4.2 years to arrive. Yes. Why? Because the radio waves travel at the speed of light, okay? At the speed of light, which would also take 4.2 which would also take 4.2 years to reach Earth. Proxima Centauri is outside the Milky Way galaxy. No, it's inside the Milky Way. Why? Because the Milky Way galaxy is around 100,000 light years. Okay, the diameter of the Milky Way is around 100,000 light years. So definitely, this star is inside the galaxy, inside our galaxy. So only one and two are correct. Okay.